Hey guys, welcome to Talent 500 YouTube channel. This is Himanshu Gupta, a software developer and a tech educator. In today's video, we'll be discussing about microservices interview questions for product-based companies. This video is going to be very helpful for all the folks out there who are preparing for their backend developer interviews. Stay tuned and let's get started. So what we'll be discussing today is, first of all, what are microservices and what existed before microservices. I will also give you an example of to differentiate between microservices and monoliths which used to exist before microservices, and then what are the problems which microservices solve for us, and when to choose what, right? Like microservices versus monolith. And in the last we will also discuss about the code which you are developing, how to differentiate if it's a microservice or a distributed monolith. Okay, so let's get started. So our first question is, what are microservices? So microservices is a software development architecture style where large and very big complex applications are now broken down into small independent applications or services, where each of these application can be now developed and deployed independently of each other. So what do we mean by that, right? So let's say you have a very big application you want to develop, let's say an e-commerce platform where you have n number of tasks to perform, right? Develop the entire experience, to deliver the entire experience of an e-commerce website, you have these n number of tasks which you need to perform. It can be payments, it can be orders, it can be products and whatnot, right? So now when you want to develop this thing, you can go about it is like one developer sitting and writing everything down in a single piece of code. Or you can say that, okay, I have these small applications which are complementary to each other, like which they need to communicate with each other, but they don't need to depend on each other to do their tasks, right? So payments only need to be told that, okay, this is the order for which this is the payment you need to collect for this user. So payments can work independently of the orders thing. So here you start looking at this approach where different small tasks can be done independently of each other. So now when these products can be developed independently, they can be deployed independently also, because let's say payment services can be running somewhere and the order services can be running somewhere, and only they need to communicate with each other, right? So for communication they use these APIs or these message queues or these messaging protocols to communicate the intent with each other. And this is how a microservice driven architecture works. So how something like that will look like for you is, so let's say for the same e-commerce, now you have multiple applications, right? Okay, so let's say this is the orders application, this is the payments application, and this is the our products application. So these are now three microservices. Inside them there can be multiple instances of each running, but they are all handled differently. Only now what in microservices architecture they need to do is they need to communicate with each other, and obviously we have all the APIs and messaging protocols for that communication, and using that they just convey whenever they want to convey something to the other, and together they give the entire experience to a user of the product. So the next obvious question is, what existed before microservices? So microservices became popular because of some of these drawbacks of this traditional monolithic architecture. So in a monolithic architecture, the entire application was developed as a single unit, where more often than not, all these units became tightly coupled with each other. They will, because if you are developing it as a single source code, and as parts of reusability of code and things like that, you more often than not will make one component depend on another component, and when it is very difficult then to make a change in one component and not affect others. So knowingly, unknowingly, these applications used to become tightly coupled with all the different components they used to have, and scaling them will also become difficult because now you need to scale them both horizontally and vertically. Why? Because scaling vertically means that when a single component is doing more and more tasks, so and if you need to now add another component, and obviously these components, all of them take their compute, take their memory. So now you need to scale this entire application vertically, because on the node, let's say a VM on which this application is running, that has currently has some n number of cores and n number of size of memory. And now when your components are asking for more and more, your this instance needs to be scaled vertically, because more components you are adding to the same piece of code, and it also needs its own CPU and memory. And now when there is a lot of user load, one instance is not going to do serve all your requests, right? So you need multiple instances to serve all the n number of users in your system now. So that means horizontal scaling. You need to scale out your system. So scaling also becomes challenging when you're using a monolithic kind of architecture, and vertical scaling has its own limitation, that it can only go up to a size which is the maximum compute and memory size available with you. Horizontal scaling theoretically has no such limit. Vertical scaling has that limit. So you when developing applications, you need to ask yourself that is your application suitable for a monolith or a microservices. So let's try to understand the difference between monoliths and microservices with the help of an example. So imagine you are building a house, your dream house, and to when you are building that, you need multiple specialists, right? Let's say an architect, a plumber, electrician, a carpenter. So you and your brother are simultaneously building a house, and let's say your brother, if in case for the specialist, your brother has hired this superhuman. Superhuman means this is a super specialist. So he knows architecture also, he knows plumbing also, he knows, and for all these four tasks which we described earlier. And you being on a clever side, or we don't know yet, but let's say you hire different specialists. Okay. So you have hired into four different specialists, and all these four specialists, they are normal humans. They are not superhumans. Okay, and your brother had this superhuman. Okay, so these are four different people now. Okay. For four different tasks. Okay, so you went with this approach. So, and now when you are trying to build your house, so what benefit your brother has with his specialist, and what you have, and what are the trade-offs when developing or architecting anything? It is all about trade-offs. Whenever you are selecting one particular architecture versus another, it is you are trading off something. Here, somewhere you will be trading off speed for efficiency, somewhere you will be trading off efficiency for latency, stuff like that. In both the cases here also, there will be some kind of trade-off. So let's say for you, first of all, the cost of each specialist will be less. Okay. Obviously, because they only know a single kind of task, so they will be costing you less. Okay. Also, when you have four specialists, so what can they do is now they can do the work in parallel. Okay, parallel work. Okay, and also when you have to, let's say, increase the speed of one of the tasks. Let's say this is a plumber, and you need, for plumbing there is a lot of work, so you need 2 plumbers or 3 plumbers. You can individually call more plumbers. They are normal humans. Okay, plus, okay, and now you have a set of plumbers, and all of them are doing plumbing at your house to speed up the process. This you can call as scaling, horizontal scaling your plumbing task. So scaling independently. Okay, scaling independently is another thing you have. Okay, and now let's say you need to replace one of the guys there. Okay, so because they are not superhumans, they are normal humans. So whenever one of let's say a carpenter here, he falls ill or something, you want to replace him, you only want to you need to find a normal human, and obviously finding that will be easier. So replacement is a little easy. Okay, so the same thing when it comes to the superhuman which knows all the tasks, what is happening. So the one thing is currently it can do one thing only. Okay, so if you want to parallelize, now you want to have multiple superhumans. So when you have this multi thing specialist, so the one thing which will go up for you is the cost, because it knows 4 different types of work. So what will be here is cost will be high. Okay, so replacement of such a person will be difficult. Why? Because it has a lot more skills than a normal technician, right? So the replacement is difficult. Cost is high, replacement is low. Okay, so now you can see, right, all this can directly translate to your applications also. So when you have a large monolith versus a small microservice, replacement for a large monolith will be a little costly. Why? Let's say your one monolith gets some error and stuff. To bring up the new instance with the new monolith, which has n number of components, you all needs to be initialized, all need to, let's say, secure some n number of connections with n databases and stuff like this. Bringing that up will take time. Okay, your parallelism now needs to be for this superhuman or this monolith. So when you are scaling out also, you are horizontally scaling each of this node which is coming as a new instance. Each of this will in individual, it's not a replacement, but it coming up of new instance will take more time instead of a microservices, because here when we had to scale a plumber, we easily find plumbers here. Finding is not a task in computing services, but you can relate finding to like how easily you can scale up a new instance. So because a microservice is a small application, they can be scaled very easily. Okay, the new instances come up rather quickly than a monolith. And also when you are running a monolith on a single instance, the cost will be high, because now this monolith is a bigger piece of code which has bigger memory and CPU requirements. So obviously the node which it is running on will have more compute and memory requirements, right? So that is also trade-off when you are running in a microservices architecture, because you don't need much compute and memory per instance, but horizontally when you scale out, each instance will take more memory and compute. So now so now we have discussed all these attributes of these monoliths versus a microservice architecture in the context of this house building, right? But if you are getting this superhuman or a monolith in the cost of same as a microservice, okay, or let's say in the cost of a plumber, you are getting a person who can do architecting, plumbing, electrician, carpenter, everything, then that's a better deal to go with. Similarly, in monolith versus microservice, sometimes the architecture will be such like that it doesn't make much sense for you to divide your monolith into multiple microservices, because the cost won't go high, and basically the trade-off which you will be doing won't give you benefits, but in turn will be will be harmful for your entire efficiency, or let's say a product quality, right? So while deciding this, you need to weigh down your choices. You need to get do some math here to see what is the trade-off, what will happen. We'll obviously discuss what kind of trade-offs there are, but you need to be vigilant about that. And there is no one architecture fit all kind of scenario. There will always be some places where monoliths will be selected, and there will always be some scenarios where microservice architecture will be more efficient to go with. So what problems do these microservices solve for us? So the first thing is scalability, independent scaling of each service to handle varying levels of traffic. So if orders are not that much in an e-commerce website, but people are scrolling through a lot of products, so you need your products microservices, which is delivering you all the list of products in each category and stuff like that. You need to make that individual service scale much more than your orders, right? So your order components, let's say only 10% of the scrolling or 5% of the scrolling results in actual orders. So your orders scale service microservice will be scaled much less in compared to your other products microservice. So flexibility, flexible deployment options, easier to develop, update and maintain your service. So deployment options are flexible in the sense that each microservice might be deployed in a different way because of the kind of architecture it has or the kind of requirement it has. Okay, if it needs to be close to the database, it needs to have some kind of cache or something like that. So you have flexible deployment options in that sense for each microservice independently, and it is easier to update and maintain those things also because they are smaller, they are much more independent from the other microservices in your system. Next is agility. So as your applications are smaller and targeting a single task, so you can have faster deployment cycles for and release cycles for such applications. So the fourth is then resilience. So at what level you need the redundancy in an application, that can be now decided at a microservice level and not at a full blown monolith application level. So that is one other flexibility you have when you are using a microservice based architecture. Moving forward, independence between services, easier to develop and maintain each service. And next is technology stack, and this is also one very important thing when you start developing microservices, is that each microservice can have its own technology stack. They need not be the same, but the only thing they need to know is how to communicate with each other. So technology stack can be different, and your specific teams working on that technology stack may have entire different skill sets which may be essential for that kind of product, and it doesn't bind you every time to develop everything in the same tech stack, right? So they have their different pros. So, and the last one is fault isolation. Like when a fault happens in one kind of service, it if you are using microservices, it will most probably not affect other microservices which you are developing, because the dependency between them won't be there. Fault happening in a microservice, that instance might you need to restart and stuff like that, but other microservices will in parallel keep running and they won't get affected by this fault at all in a microservice. So when to select microservices versus monolithic. So this is not an exhaustive list, but this will just give you a standpoint of what kind of challenges a microservice versus a monolith can get, and when you are in the initial phase of your project, so how do you quickly go on to a decision of what you want to do, or how you want to architect your service, right? So microservice you might want to select when your application is very complex and it has n number of components which are interdependent on each other. Microservice architecture will help you in defining the interdependency in terms of contracts, and these contracts can be rock solid, and as they are deployed and developed parallelly and simultaneously among different teams. So the only way you convey yourself is with using these contracts, and that will bring some simplicity to your complex architecture. The second is for monoliths, it could be when your architecture is relatively simple and you have only a few components which needs to communicate with each other. At that time, you might want to go with the monolithic architecture. The second is you want to have a highly scalable application, both in the terms of the deployment, like they need to handle increased traffic, and also enabling distributed teams to quickly go on to developing and delivering the product, right? So at that time, microservice architecture might help, because if you have n number of teams and n bandwidth, then you might want to speed up the process by having these n teams developing in parallel. And also when you have this microservices architecture, and as we already discussed, when traffic increased in one microservice, you can scale it independently of another, and will help you save costs in some cases. Monoliths you might want to go with when you want to quickly come up with the beta product, and with minimal overhead like designing contracts and all. You don't want to do that. You just want to give away with the beta release, which in a single code snippet which does everything for you. Okay. The third point is when application need to be highly fault tolerant, and you need to isolate these failures. So these are basically the benefits of microservices over monoliths, but structured in a way which how you can quantify, like now I want to select microservice or a monolith. So when you need to isolate failures, such that failures in one kind of application or what component doesn't affect other, you might want to select a microservice versus a monolith. And fourth one is your organization is large and diverse, and that is a big organization, and you have different technology stacks, and some components need to be built in one and some to be another because of n number of reasons. Maybe let's say compliance, or your application requirements are like that. So at that time also you might want to go with the microservice architecture. Whereas if you have a small development team and you want to limit your using multiple technology stack, because that will increase your investments in the entire project, you might want to select monolith. So from business point of view, this difference gives you clarity, like in the initial stages, how you might want to select a microservice versus a monolith architecture. In technical perspectives, when we say the real efficiency or say latency and stuff like that, when then that comes into picture, then the ballgame can be entirely different, and we will discuss in upcoming videos that will bring some new points of discussion on the table when you want to select a microservice or a monolith. This is just business standpoint of view, that what is the need of the hour. So now how to distinguish between what is a microservice or a monolith, or let's say a distributed monolith, because sometimes you go on developing, or you thought that okay, we'll go with the microservice architecture, but your development process or the entire way you are developing that might not justify it as a microservice, but might justify it as a distributed monolith only. So we'll discuss here what makes your service more of a distributed monolith than a microservice. And if you are developing a distributed monolith, the only thing you are doing is making your code slower, because everything is still dependent on each other. They are not independent, but the only thing what you have done is added more latency for your application, because now they have to hop on over the wire network calls to communicate with each other, but they are still the monolith, because if one goes down, everything is going to go down. So what are these factors? So one is tightly coupled components. So if a change in one of your service cause a redeployment of other services, then you are up for a distributed monolith, because your microservices should be so much independent that in most of the cases one component change should not cause change in other. Okay. The second is a centralized data management. Let's say all your microservices use or work on the same data or the same database, and again you are in kind of an monolith architecture only, because if database is not working properly, or if database is a little slower or goes down, your entire microservice, all the microservices which you seem are microservices, will go down. Basically, the data management has created a tight coupling between all your applications, and thus that kind of application is also a monolith only. So the third is your monolithic code base. So if all your microservices are in a shared code base only, they have a same test environment and everything is same, so when it will become very difficult for you to update one of your microservices and push it out, right? Because test environment is same, the code base is same, so more often than not you will be changing one thing, but it will be impacting other part of your code also. So if you have a monolithic code base and you are developing a number of microservices in that, then it's again a monolith only. So the fourth point is dependency on fast communications. Okay, so your microservices they have this requirement that you need low latency communications. So we aspire for low latency communications, but it doesn't mean that if the communications are a little weak or little slow, then your application is gonna fail the request or something like that, right? So that should not be the case. If that is the case, then it's better that both of those components should be at the same machine, and there is no wire transfer, but like the network call is not there, but only memory read write calls are there, which are way faster, and that means that you are not on a microservice path, but in kind of a monolithic path only. So the next point is your development process and the pipeline also. So if the single team is responsible for developing all the microservices, then that again becomes a monolithic development process, and in a kind of monolithic distributed monolith for us, and also the deployment pipeline. If all of your microservices use the same deployment pipeline, then obviously when you are deploying one, you are redeploying all the entire application, and that is also an indication that your services are kind of monolith only, and not following the best practices of a microservice architecture. If you enjoyed today's content, please do not forget to like the video and subscribe the Talent 500 YouTube channel. We'll keep on bringing such amazing content for you in the future. And also press the bell icon so that you get notified whenever we post such content.